everybody. Section 2-5 obviously is about scatter plots. Scatter plots are kind of like a graphical representation of a bunch of ordered pairs, like data points that are kind of comparing two different variables, right? So kind of like on here we have a table with comparing data on like the number of weeks a website has been online and corresponding with the number of visits to that website in the thousands. So for example, like after 1 week there would have been 2.3 thousand visits, or 2,300 visits, and after 7 weeks there would have been 14.9 thousand visits. Okay, and when you graph that, so question A, not the question that we're most concerned with, making the scatter plot. That's just a matter of like plotting all of these as points. I'm going to go ahead and assume that we're all like fairly capable when it comes to this. So 1, 2.3, because down here we're kind of going by ones. This is like 1 week, so down here's the weeks. 1 week, 2 weeks, 3 weeks, 4 weeks, 5 weeks. And then along this edge, this upper vertical axis, would be like the number of visits. And it looks like this is making jumps of like 2 or 2,000. So like 2,000, 4,000, 6, 8,000, 10,000. And so plotting all of these would be like 1, 2.3, and then 2, 4.7, all the way up to 15, 33. And again, you don't have to be like super worried about being like really exact. A lot of these points you're just kind of like doing the best you can with where they're supposed to be placed. But that is a scatter plot, and it's a pretty good name because it just looks like a bunch of scattered points, a scattering of a bunch of dots to make a scatter plot. But what you hope for is that all these points show a trend, and therefore like a relationship that exists between the two variables. So as you can see here, like the dots seem to be forming a trend, and therefore the number of weeks a website has been online, there's definitely a relationship between that and how many visits there's been, how many hits there's been. But again, this is what a scatter plot is, and what we're going to be more concerned about is like answering questions based on the scatter plot. Not so much making the scatter plot, that's not our concern. We're going to be answering questions based on the scatter plot like this. So question B, does the scatter plot show a positive correlation, a negative correlation, or no correlation at all? So like I already said, these points are showing like a trend, and it's an uphill trend. It's like these dots are pretty much forming a line that's going uphill. And when you have like an uphill sort of trend, that's going to be a positive correlation. So a positive correlation is when it's kind of all going uphill, And to elaborate on that, when you have the dots going uphill like that, that means that when one variable increases, the other variable also increases. And the same goes, if it was like decreasing, then the other variable would also decrease along with it. So they would increase together or decrease together. A negative correlation, you might be already guessing, or you might already know, is when it's kind of like a downhill trend and the dots seem to be forming like a line, but it's like a downhill line. And that's a negative correlation, and that means, when one variable increases, the other variable is decreasing. And vice versa, if the first variable decreases, then the other variable would increase. And then no correlation at all would be just kind of like a random scattering of dots that aren't really forming any trend at all. They're just kind of all over the place, meaning there's like no relationship, between the two variables whatsoever. Okay? And I can never think of an example. It's almost like the temperature outside compared with like how much toothpaste was purchased at Walmart that day or something. I don't know. Like two quantities that have like nothing to do with each other. You know what I mean? So anyway, question C, we get into some predictions. Predicting is a major, major, major thing with scatter plots, and I'm thinking of the keystones right now. Inevitably, the keystones are just part of our deal. So, but the keystones are big on making predictions. So this one says, predict the total number of visits to the website after 20 weeks online. And why am I going that way? 20 weeks online. And so when you make predictions, this is where you want to bust out the line of best fit, or the trend line. Okay? And the line of best fit is just just like it sounds. It's the line that you think might fit the dots the best. One line through all the dots at the same time. And it's almost like, sometimes it's hard to tell, exactly, how or where you're going to draw that line. You just got to eyeball it the best you can. It's going to be like an estimation, pretty much, if you're doing it yourself. Hopefully, in ideal situations, you already have a trend line drawn for you. But if you got to draw your own trend line, your own line of best fit, just do the best you can. There's not really any exact science to do it. Some rule of thumbs you might hear about involve, like put the same number of dots on both sides of the line. But really, I think you just got to kind of go with your gut and draw the best line you can. Because once you have the line, now you can kind of just like go with the line. You could ignore all these blue dots and just kind of stick with the purple line. And making a prediction for week number 20, you can just kind of go up on your line, right? So week number 20, if there was a dot, or if you had to draw a new dot that was in the spot that it would be in for like the 20th week, it would be right there on the line. Like that's where my best guess of a dot would be for that 20th week, right on the line. And the corresponding number of visits would be 40, or 40,000. Now, just to kind of a couple more comments. This was easy just to eyeball, because the 20th week was definitely in bounds. You could just kind of like look up to your line to see where the dot would be. But compare that with question D, predict the total number of visits to the website after 52 weeks online. 52 weeks? Look, 20 weeks, 21, 22. Week number 52? That's like way out of bounds. That's off the page. That's off the screen. You can't exactly eyeball, you can't exactly like draw your line and keep your line going, drawing your line, and line it up with week number 52. You have to kind of use a little bit of cleverness, or like a different sort of problem-solving strategy, other than just like looking at your line. So you might notice here that, I don't know, it looks like we are, crossing through that point makes sense, right? 0 weeks, 0 visits. So having my line definitely hit that exact spot makes a lot of sense to me. And then we have this spot over here with like after 20 weeks we had 40,000. I guess you could sort of think like, well, that rate, is going to kind of continue. So based on that logic, you could kind of like realize that, okay, every 20 weeks, we're gaining 40,000 hits. Or actually, to kind of drill down even more, it looks like, look, boom, 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 boom. Sort of like, so we can say like every week, this is even better. Every week, it seems like we're gaining roughly 2,000 visits. There's 2,000 more hits, every week. So you can kind of use that rate to kind of think about, how many hits there would be after 52 weeks. And that, my friends, is basically using the concept of slope without even realizing it. Like when you say 40,000 hits every 20 weeks, or if you kind of simplify it down to, every week there's going to be 2,000 hits, that's essentially saying the slope of your line. The other way, to answer this, if you were going to go like full algebra mode, like fully algebraic with this, you could use that basically the same strategy and kind of say, well, I know that we could say like 0, 0 is a point. And heck, we could go with 20, 40. Of course, at the end of the day, we know that 40 is really 40,000, but just kind of keep that in mind. I'd rather keep it as 40 than 40,000 for, while we work, okay? But and you could take these 2 points and you could make an equation. And you could have like the equation of the line, and using your equation, you could figure out 52 weeks. Might as well do that now. I was going to wait until like the next video, but might as well do it now. So remember how we do y minus y1 equals m times x minus x1. Okay, I'm going to go ahead and use 0, 0 as my point. So I already know I'm going to be plugging in like 0. I mean, what's better than plugging in 0? That's very nice. Like this is going to be very convenient actually, having 0, 0. So what's my m? Well, we're going to use both of these points to get my m. And so like 40 minus 0 all over 20 minus 0, which ends up being 2, which we've already realized, 2 or 2,000 visits every week. But hey, it looks like our m is going to be 2. Okay? And so when it's all said and done, we have an equation of y equals 2x. Now remember that my x variable is essentially the number of weeks, and my y variable is my number of visits. Now in this equation, my y is going to be like just the number of visits, but then you'd have to like say 1,000 after that. And so what you could do here is take this 52 and literally plug it in for x, because it's like an x value. It's a number of weeks value. And so I believe this is going to be like 104, or really 104,000 visits. So that's my answer, 104,000 visits. Let's see if this next example is pretty much a repeat. I don't know if there's going to be any new revelations, so plot the data points. Again, this is not what we're focused on here. I hope we have the chops to be able to kind of scale out, an x-axis and a y-axis that fits our sort of scenario. Looks like down here I'm going by 1, but kind of up on the left side, are we going by 20s? 20, 40, 60, 80, 100. Yeah, so, and then, as sort of like zoomed out as this is, I assume we can kind of like plot these points at least pretty good. Like, don't stress yourself out going, where's 539 exactly? Oh my God, don't worry about it. So like 13 comma 539, 13 comma 539. I mean, look, I put it right there. It's not like I knew exactly where 539 was. Just kind of do the best you can. But again, the bottom line is, again, for like the third time I'm saying this, I'm not concerned right now about building these skills. You should already know how to plot points. And, I already have this line of best fit drawn here for you. So I assume you have to draw this yourself. I can't remember. Yeah, you have to. I mean, it has to be, right? So you're going to be drawing this line yourself. It looks like my line that I drew here. So listen to this part. Make sure you listen to this part, okay? So if your notes are going to match my notes, it looks like my line of best fit is passing through that spot, as well as essentially, let's say this spot right here. Okay, which is, it looks like that's 25 comma 900. Is that right? Let me double check that. 25 comma 900. What were these numbers relating to, by the way? Temperature and the number of skiers. Yeah, I would say there was a relationship there, right? Wouldn't you say? Are we going to ask about the correlation? No. So let's talk about that really quick. So we drew our line, and remember, if you want your line to match my line, right there at like -7 comma 0, it looks like. -7 comma 0 and 25 comma 900. Okay. It looks like, gosh, I don't want to confuse anybody here, so just listen carefully, right? Normally, right, gang, you would think the colder it is outside, the more skiers you would have. So my first thought, like 20 seconds ago, was, ooh, this might be a negative correlation. This might have like a downhill trend, And that's true, right? If I had like different values in this table, maybe more closer to like, 30 degrees, 40 degrees, 60 degrees, 70 degrees, you might actually see like a negative correlation downhill trend. But I guess with these values, like maybe like in this domain, there's a math word, it's almost like, ooh, -5 degrees. You're not going to have more skiers. You're going to have maybe, I don't know, I guess it depends. But I guess according to these numbers, the temperature drops into like crazy cold temperatures. You're actually going to have like less skiers. So whatever, don't overthink that. But here, the bottom line is these numbers, whether unrealistic or not, it looks like these numbers are creating a positive correlation. The more the temperature is rising, for these numbers, it looks like we're having like more skiers. Maybe that's unrealistic, but whatever. Let's go with it. So we have a positive correlation, and so draw the line of best fit. Check. Find the equation. Okay? Don't be surprised if that's like a mandatory question. Find the equation. So here we had our points negative 7, 0, and 25, 900. You want, again, just to make, I want to be crystal clear here. You want to use points that are on your line. I don't care about this purple dot or that purple dot. I don't even care about that purple dot. I don't even care about that purple dot. Okay, which looks like it might actually be on my line. You want to use points that are like on your line. And, 19 times out of 20, you're going to have to name 2 new points. And guess what? The farther apart, the better. You might even want to write that down. The farther apart you pick your points, the better. See, I did that here on purpose. Look at how far I chose this point down here, and I chose this point up there, and the farther apart, the better. And you want to pick points that are like on your line. So negative 7, 0, and 25, 900. Let me just write this down again. And 25, 900. So again, we want the equation. The first thing is we need m. So m equals 900 minus 0. So y2 minus y1 all over x2 minus the negative 7. Remember, people, there's a negative built into the formula, and we had a negative 7, so it looks like it's going to be like basically 25 plus 7. So we have 900 divided by 32. And I don't think that's going to be a very clean division. This can get messy, man. That can't be, yeah. Well, you know what? Hey, you know what I say? Let's go with this decimal. This looks like a nice enough decimal. Why the heck not? There's no absolute rule that you got to keep it as a fraction. I wouldn't do a nasty decimal. I don't know if I don't know. This is like a whole conversation unto itself. Do we want to leave it as a fraction? Can we feel okay with rounding off the decimal, kind of thing? I guess I always say this: if this was multiple choice, you'd be sort of controlled by what your choices said. If your choices all had slopes that were fractions, then you'd have to pretty much go with that. You know what I mean? But I don't know. It's kind of like an open sort of thing. I don't know if there's really strong rules. Really, as always, the more exact you are, the better in everything. But I'm just going to go with 28.125. Whatever. And so now we have y minus, and let's go with this one. Y minus 0 equals 28.125 times x minus the negative 7. Right? So y minus 0 is just really y. And then over here, what that really says is x plus 7. So as I distribute, I'm going to think of it as the 28.125 times a positive 7. But first, 28.125 x, and then calculator time. 28.125 times positive 7 is 196.875. So there is my equation. And again, if we were all going by this line that I drew, that went through what we're calling, these 2 points, then, that's an equation we should have, or something equivalent where, maybe instead of 28.125, you have an equivalent fraction, just 196.875, you would have an equivalent number, but maybe as a fraction. Whatever. Again, sometimes you're controlled by, what you see in like multiple choice or something. And then question 4, using your equation, estimate the number of skiers that would be out on a 37-degree day. Goodness. So 37 degrees, I mean, let's see, 31, 32, 33, 34, 35, 36, 37 would be like kind of out here. I suppose you could make sure your line extends a little bit more if you had room on your paper or whatever. And you could eyeball this, I'm sure, right? Go up and draw a dot on the line where it would be for what was this, 37? For 37 degrees. But I mean, if it says use your equation, yeah, because if you have an equation, use your equation. Okay? Like that's a pretty reliable method, because remember, your x values are temperature values, and your y values are numbers of skiers. So if they're telling you 37 degrees, they're essentially saying x equals 37. So you can plug that in, plug it in to the equation. So y equals 28.125 times 37 plus 196.875. I hope I haven't made any mistakes. 875. Okay, so calculator time. Let's evaluate this all out. 28.125 times 37 plus 196.875. So that would be about, looks like 1,237.5 1,237 and a half skiers. So yeah, like that can't have half a skier. But again, do you round? What's your answer? Sometimes you're just choosing the bestest multiple choice answer, blah blah blah. But the main point is, if you have an equation for your line of best fit, you can just like plug values in to make your estimate. And it's not always for x. They could trick you a little bit. Okay, listen, they could say like how cold, or what would the temperature be, if there was like 1,500 skiers? What would you sort of assume the temperature was if there was like 1,500 skiers, there at the resort or whatever? Then you would plug in 1,500 for y and solve for x, right? Because they were giving you a number of skiers, not a number of like degrees of temperature. Okay, but that's the first round of scatter plot stuff. Again, just like going over predicting using your graph, making predictions using your graph, making predictions using like the slope of the line or the full equation of your line, and basically sometimes the whole question is just revolving around what is the equation. Like sometimes that is the problem, that is the question. What's the equation? And then you can use the equation to make predictions. But so that's the first part of our scatter plot lesson.